Well, it's official. Marlin 2.0 is here. Marlin 2.0 has been around for a little while now. We've done 8-bit installs, 32-bit installs, we've checked out some of the features that Marlin 2.0 brings, but all those releases were bug fix versions. We now have an official release of Marlin 2.0, and I've been planning content for this release for a while now. I thought it'd be a good idea to run through some of the topics that I did previously in the 1.0 version, just as a bit of a refresher, and a few things have changed with the 2.0 version. I also thought it'd be a good idea if we started with auto bed leveling. I did an ABL video back in 2017, but a lot of things have changed with that process, and I thought it might help new users, especially when working with a 32-bit board. So let's get started at looking at a couple different types of probe, and I'm going to show you how to install this on an SKR 1.3 mainboard. So let's get into it. So here's our SKR 1.3 board, and the easiest type of sensor, in my opinion, to install is the inductive probe. This is an actual Prusa Pinda probe. It's a PNP sensor. I'll explain the difference between PNP and NPN in just a second, but you're just going to have 3 wires for the most part on these probes. A lot of these probes will be rated for 6 to 36 volts. Those are a little more difficult to use. I highly recommend you try to find a 5-volt version. The 5-volt versions are readily available from AliExpress, as well as the Prusa Pinda probe. You can use that on pretty much anything. The Pinda 1 probe, it's also 5 volts. When looking at the wires on an inductive probe, most commonly the brown is going to be your voltage in, your blue in the center is going to be the ground, and your black wire is going to be your signal. And if you get the 5-volt sensor on an SKR board, we're going to use the Z minimum end stop plug right here. On this board, the signal pin is located here, ground in the center, and voltage on the other side. That makes it perfect to plug in your inductive probe. It'll plug in just like this. Most of the time you can just use this connector. It's not the appropriate connector for this board. These are JST type, but a lot of times I'll just pull this plastic cover and use the straight pins for this type of connector, or swap this connector over to JST. These actually do fit pretty tight on those pins. And that's all you have to do, besides firmware changes, to use this type of probe. And the other common type of sensor that I see for bed leveling is the BL Touch. The BL Touch actually has a bit of a mechanical aspect to it. You deploy this probe, you touch the probe to the bed, and then you bring back a reading. It generates a map the same way as an inductive probe would, it just works a little differently. The biggest difference on the BL Touch is you have to have a way to deploy that probe. The most common way to do this is with some servo pins. On your BL Touch, you have 2 sets of wires. You have the set that I like to call the servo wires, and then you have your end stop wire set. The end stop wires are pretty easy. They go to your Z minimum end stop just like an inductive probe would. The black wire will go to ground, which is the center pin, the white wire for the signal. So just like this on an SKR board. Now the servo wires are a little tricky with the SKR because they're not wired in the same order as a lot of boards are. On the BL Touch servo side, you have your brown wire that's ground, your red wire that's 5 volt. It can be 3.3 volts on some of the newer versions if you alter the sensor a bit. And then your orange wire, which is signal. And right here are the servo pins you're going to want to use for your BL Touch on your SKR board. But if we flip it over, you can barely read that, but the pins read 5 volt, ground, and then they give you a P2.0 pin. This should serve for the correct servo for your BL Touch, but the wires are swapped. The BL Touch, by default, has 5 volt on the inside and ground on the outside. So to use your BL Touch on your SKR board, you're going to have to rework your plug a bit. You're going to have to swap the brown and red wires on this end. So for the SKR, your red wire will be on the outside, brown wire in the center, and your orange wire on the other side. And it'll plug into the servo pins on the SKR just like this. 5 volt, ground, signal. Then you should be good to go with the standard config in Marlin firmware to use your BL Touch. So as far as the hardware side goes, this is as far as I'm going to take it in this video, because most of the time when you see an ABL sensor, it's either an inductive probe or a BL Touch sensor. And even if you have a different type of probe, it's going to wire up pretty much the same way. Everything else in the video is going to be all about configuring Marlin. So let's jump into the code and get all that set up. So the first thing we are going to do is head over to Marlin and grab a fresh copy of Marlin 2.0. marlinfw.org. We'll go to Downloads, And as you can see right here, the latest release is officially 2.0.0. We'll grab that zip. We'll head to downloads and we'll do an extract all. Now that we've got it extracted, I'm going to open it up in VScode. We'll open VScode. So we can just hit add folder. We'll go to downloads into our Marlin 2.0 folder. We'll highlight the subfolder and just hit add. We're in File Explorer mode. We can just expand it here. We can expand Marlin. And here's our configuration.h and configuration_adv.h. We can go ahead and open both of those up. And we'll start in configuration.h. In this video, we're just going to focus on the things you need to do to get auto bed leveling set up. Everything else for this configuration has already been set up to work with my printer. I have previously done step-by-step configurations of Marlin for 3D printers. If that's something we want to walk through in Marlin 2.0, leave a comment below. But for the bed leveling setup we're going to do today, we'll start in the in-stop section. We are going to home at 000, so the tool head will be at the bottom. So we're going to use Z-min plug for our probe. In-stop pull-up should be enabled, but that should be enabled by default. And then we come down to in-stop inverting. For this tutorial, we're mainly concerned with Z-min and Z-min probe in-stop inverting. If you have an NPN probe, you're going to want to set both of these values to true. If you have a PNP probe, you're going to want to set both these values to false. NPN, the light on the top of the probe, is not triggered until the sensor is triggered. PNP, the light is always triggered until the sensor is triggered, then it'll go off. That's the easiest way to tell which probe you have. I have an NPN probe currently installed on this printer, so we're going to set Z-min in-stop inverting to true, and Z-min probe in-stop inverting to true. These values have to be the same or it won't compile. Moving on, we come down to Z-probe options. By default, Z-min probe uses Z-min in-stop pin is uncommented, and that is exactly the feature we want to use, so we're just going to leave that default. If you're not using your Z-min pin, some of these other options will help you reassign it to another pin. Then we decide what type of probe we have. I have a fixed mounted probe, so I uncomment this line right here. If you have a BL touch rather than an inductive probe, you can leave this line commented and uncomment this line. By uncommenting the BL touch line, that assumes that you're using the Z-min probe for the probe portion of the BL touch, and then your servo pins for the motion of the BL touch. Other than cabling up that servo, it should work exactly the same as an inductive probe. But we're going to stick with fixed mounted probe for now, so we'll comment out BL touch, and we'll go with fixed mounted probe. Then we come to probe offset. This is where your probe is physically located in relation to your nozzle. And this is an important concept to grasp when you're trying to set up auto bed leveling. These measurements are considering where your nozzle is located, not the probe. And you'll see more of that as we go through here. But my probe is to the right and behind the nozzle. And you can see from this chart, if it's to the right and behind, it's going to be a positive number. If it's to the left or in front, it's going to be a negative number. I'm using the Prusa Mark III's extruder body, so my probe location is X23 and Y5. We'll leave the Z offset to 0 for now because we're going to have to calibrate that later. And just to make it a little more clear, you can see that my probe is on the right of the nozzle and behind the nozzle. If you're not sure what your offset is, you can just measure it with a ruler and punch in those values. The next setting we're concerned with is minimum probe edge. If you have clips or something around the edges of the bed that you need to avoid, this setting can help with that. This will make sure that you're a certain measurement away from the edge of the bed so you can avoid those areas. I don't have this issue, and on a Prusa bed, I just set this one to 0. Because when we're probing the surface, I can get all the way out to the edge without colliding. XY probe speed, this is the traveling speed in between probe points when you're doing the sequence. 8,000 is a good number to start with. Z probe speed fast. If you're doing multiple probes, this is going to be the speed of the first one, the fast probe. Any probing you do after that, if you're doing 2 or 3, are going to be slower. We can just leave it at the homing feed rate. And Z probe speed slow, this is going to be the speed that it probes of anything after the first probe. The accuracy probe. Multiple probing, I do like to do a couple just to make sure I'm getting accurate measurements. So I'm going to uncomment this line, and I'm going to set it to 3. The more probes you make, the better chance you're going to have of being accurate with those measurements. That's pretty much all you need to do in the probing section to get started. Now on to bed leveling. For this video, we're going to do one of the most common types of leveling, and that's bilinear. There are a handful of other types. I have videos for a lot of these, but bilinear does a pretty good job, and it's pretty easy to set up. So we're going to uncomment auto bed leveling bilinear. Restore leveling after G28 is an interesting setting to mention. Most of the time, if you G28, then G29, G29 will execute the leveling. If you G28 again, you're going to wipe out that leveling map. If you uncomment this line, you can G28 again without wiping that out. It can be useful in certain situations. I tend to do a G29 before every print just to make sure it's all level and ready to go, so I'm going to leave this commented. But it is there if you need it. Debug leveling feature, this is going to get you a lot more information about what's going on with a 28 or a 29 for leveling. We shouldn't need it for this tutorial. I'm going to leave it commented out, but it is there if you need it. And by default, you have a lot of these features enabled when you use bilinear leveling, but just to touch on it a bit, enable leveling fade height. This is an interesting setting. Basically, you have a height set where the leveling is no longer applied. It's going to gradually reduce the correction that you've made with that bed leveling until a certain height is reached. By that height, the print should already be level with the X and Y plane, and it should just continue as normal. Then we can move down to grid points. This is how many points that you would like to probe when you do your G29 sequence. If you set it to 3, that's going to give you 3X and 3Ys for a total of 9. For the Mark 42 bed that I'm using, it does have 9 points, so I'm going to leave this set to 3. The more points you have, though, the more accurate you're going to be on your bed level. So you might want to play with this setting. You can also switch to probe Y first if you'd like. I know Repetier does Y first, but Marlin always does X first by default. But here's the option if you'd like to switch it. I'm just going to leave it to probe X first. And that should be really all the things we need to look at to get bilinear set up by default. It is going to just pick 9 points that are evenly spaced in a grid to probe by default. A lot of beds, that's just fine. The Mark 42 has specific locations that it wants to probe in. There really isn't enough copper all over the bed to just probe anywhere, but if you have something like a spring steel sheet, this is going to work just fine with your printer. How big the grid is based on the bed size you have set in Marlin. Again, that setting should have been set up when you were configuring Marlin the first time. And another topic I want to touch on in this video, it isn't really related to AVL, but that's Z-safe homing, and I have to use it on this Mark 42 bed. Since I home at 0x and -2y, I'm actually a little bit in front, I'm not going to be able to hit the first probe point when I do my homing. So that's where we can use Z-safe homing to take us to that point before we do our homing sequence. So we'll uncomment Z-safe homing, and I'm going to change up some of these defaults. By default, it's half of your bed, X and Y, so the center of the bed. But I want to probe at the X point 31 and the Y point 9. And to figure out where those points are, you can just do it with a ruler. Set your print head to your front left corner and measure from the nozzle to the spot that you would like to probe. Remember, you need to go with the nozzle, not the probe location. And if you want to increase those homing feed rates, here's those settings right here. Now, that's really all we need to do to get a generic bed leveling sequence set up in Marlin. But here in configuration.h, there used to be settings where you could select specific points where you'd like to probe. I do have specific locations on this bed that I would like to probe. There are specific spots on a Mark 42 that I need to hit. And those settings aren't in configuration.h anymore. They're in configuration_adv.h, and they work just a little bit differently nowadays. And those of you not familiar with the Mark 42, it has these spots on it where it intends for you to probe. If you hit these spots, you can't see a lot of them in here, it's going to give you a lot more accurate reading than if you just try to tag anywhere on the bed. So I need to get to those locations. So if we jump over to configuration_adv.h, you can do a Control F to find, and you can search for probe _selected. And for bilinear bed leveling, here's where all those settings are. Now they have changed them up a bit. Let's just uncomment all 4 of these. So the left and front probe points haven't changed at all how they work. You can just move your tool head all the way to the front left. Of course, this is for a Cartesian machine. You can use your ruler to measure to the point where you'd like to probe and then record those values. So my left point, the nozzle will be setting at around a 31. And my front point, it will be setting at about 9. So my nozzle's in the front left right here, and then I'm just going to move the tool head so you can see. but the center of my probe point is around a 31. Same for the Y, the nozzle's over in here, but it's going to be around a 9. Pretty simple, just measure it with your ruler. Remember, go from the nozzle point, not the probe. But then we have the right and back settings. Before, you'd enter how far you were going to travel to that right point or that back point. Now it's actually the opposite of that. Now you're going to use the value from the edge of the bed to where the nozzle would be during that probe point. So I'm going to move my tool head so the nozzle is right in the center of my probe point, and I have my bed settings set up in Marlin to be a 250 by 210. So I'm going to measure from where that nozzle is in the center of that probe point to the edge of the bed. I'll slide this out of the way just so I can show you. But to the center of that probe point, to the edge of the bed, I'm setting right about 15. So back to Marlin, my right probe edge is going to be 15. And we do the same kind of measurement for the back. We'll move the Y all the way forward, nozzle over that probe point, and then we'll measure to where the end of the print area is, the one that we have set in Marlin. I have it set to 210. That's the size of this PEI sheet roughly. So I'm just going to measure to the edge of the PEI sheet from the center of that point. And I'm setting roughly at 4 millimeters. So my min probe edge back, we're going to set that to 4. So that should get me to all the locations where I need to use the probe. And there might be a little bit of trial and error here if you're not getting exactly in the center of those probe points, or you want it to be just a little bit closer, or you have to move around a bit, you can adjust the values again. And for these values, you can get as granular as you want. As I said before, most of the time if you're using a steel sheet or you don't have specific probe points, you won't even need to set this up. I just wanted to show you it because it has moved, and so if you need to use it, it's in configuration_adv.h, and this is how it works. Now there is one more feature I want to enable because we're setting up bed leveling. This is going to make things a lot easier, and that is baby stepping. So let's just do a find on baby, and that'll get us to the baby stepping section. We're just going to uncomment this line. This is going to enable us to make small incremental changes in the Z offset so we can adjust how close the nozzle is so we have a good offset for our Z probe. We can do this on the fly with baby stepping, and then we can record the value later. So we'll just leave these two uncommented. You really don't need to baby step X and Y. We'll leave baby step invert Z to false. Baby step multi-factor, I want to change it from 1 to 0.5. I want it to be just a little bit more granular. I'm going to uncomment double click for baby stepping. That way when a print is running, you can double click the LCD knob and that'll take you to this setting. And then down here, I'm going to uncomment baby stepping Z probe offset. By default, baby stepping is just a measurement on the fly that's going to get reset every time you G28. If you uncomment this setting, this will make it your Z probe offset until you power off the machine. We're going to use baby stepping to get that number, and then we'll save that number in Marlin and in EEPROM so we have it through reboots. And that should be all the things we need to change in Marlin to get auto bed leveling set up and working. I am using the SKR 1.3 mainboard on log right now. I have the printer powered on and plugged in USB. I'm going to head over here to the Platform I/O button. I'm going to select my environment, LPC 1768. I'm going to hit upload. The upload is complete. Now we can finish the setup through Pronterface and we'll get the hardware set up. Remember, after your upload's complete on a 32-bit board, you want to power off and power back on the machine. From Pronterface, I'm going to go ahead and connect up, and I'm going to preheat the nozzle because I want to clean the filament off, and I'm going to go ahead and back out that filament so it doesn't leak everywhere. And while you're preheated, go ahead and clean the nozzle off. We don't want any filament on it while we're trying to do this. And then we can go ahead and switch the hot end to off. After we're cooled off and we make sure the nozzle is clean, we're going to get to kind of the front center part of the bed, and we're going to manually turn the Z-rods until the nozzle is just touching the print surface. You also want to loosen up your Z-probe holder because we're going to have to move it and adjust it a bit. And for most of these inductive probes, you want to shoot for around 1 millimeter higher than the nozzle. That's going to work for a lot of different print surfaces. And the easiest way to do this is to use a zip tie. Most of the time, your smaller zip ties are going to be around 1 millimeter thick. So we'll slide the zip tie onto the probe, and while it's loose, we're just going to push the probe on top of that zip tie. It doesn't have to be real tight on top of that zip tie, just touching it. You do want to make sure whatever mount you're using for your probe, that probe is nice and level to your bed surface. the more square the probe is to whatever you're trying to trigger it with, the better off you're going to be. So that's a great starting point. We can go ahead and tighten up our probe mount and remove our zip tie. At this point, you're probably pretty safe that you're not going to crash the nozzle into the bed if your probe is about 1 millimeter higher than the nozzle. Again, that's not for every probe, but most inductive probes that you're going to see on printers, this is going to work just fine. So let's go ahead and send it a G28 to home the printer. The homing was successful, and we are really close to dead on in the center of that spot. We might be able to go up maybe a 0.5 millimeter, but that's probably close enough for my needs. And before you start the leveling sequence, you want to do an M503 and make sure that there's nothing hanging around in EEPROM. Right now I have this M851 command. That's how you set the offsets. It still says Z negative 0.8. We want to make sure that's set to 0 because we've moved the probe and now we need to readjust it. So the easiest thing to do is just to run an M502 to load the defaults from the firmware, and then you can save that with an M500, or you can adjust that offset with that M851 command. M851 Z0. And if we do an M503 again, you can verify that it's set to 0. Anytime you do the EEPROM commands, you need to save them with an M500. So now we'll go ahead and G29 to start the leveling sequence. And the leveling is complete. Let's jump back to Pronterface. When you're plugged into the terminal and you do a G29, it's going to spit out the results of that leveling. So you can read the results from the front left corner here at 0, 0. My bed's just a little bit all over the place, but nothing bilinear leveling can't handle. So now we need to set our offset. So we're going to manually move the nozzle to the center of the bed. So let's do G1, X 125, Y 105. That's just half of my bed size, and then we'll put Z at 10, just to make sure we don't scratch the bed surface. And we can move it at a feed rate of 5,000. Now we're in the center of the bed. Now we're probably going to have to go into the negative to be able to set our Z offset correctly, so we're going to have to disable software in-stops. Software in-stops is what keeps you from crashing into the bed. You're not allowed to go into the negative movement, but we have to set this up. To turn that on or off, we can do the M to 11. It's currently on. If we set it to an S0, M to 11 S0, that's going to turn it off. Now we can go in the negative. The easiest way for me to show you how to do this is to just get a piece of paper and put it underneath the nozzle. And then we're going to lower Z about 5 millimeters, make sure the nozzle isn't touching, and then we'll continue to lower it. We did set it to 10, so we should have quite a bit of room. Let's lower it 4 more. We're still not touching. We can do an M114 to see where we're at. We're currently at Z1, that's where we should be. Now we'll start lowering 1/10 of a millimeter at a time. We want to bring it down until the nozzle grabs the paper. The nozzle now has a hold of the paper, so I'm just going to go 1 up to release it. And that should be a good starting point for your Z offset. So we can do the M114 again. Our offset is negative 0.4. So we can run an M851, Z negative 0.4. And we'll do an M500 to save that to EEPROM. We can do an M503 just to make sure. And here's our offset settings. We can also update that in the firmware if we want to make changes later. Now I think the easiest way to fine-tune your offset is to just start a print and use baby stepping. So let's preheat. We'll get some filament loaded. And we'll kick off a print. We'll home. We'll run our leveling sequence. And while the print's running, if you double-click the knob, that's going to take you to the baby stepping. It's currently set to 0.4 because that's what we set our offset to in EEPROM. And that first layer actually looks really good. I really don't see any need to make any adjustments. But if you're too close or too far away, you don't like the way the first layer looks, you can adjust it right here. In the negative, we're at a 0.4. If you lower that number, that's going to get you further away from the bed. If you raise this number, that's going to get you closer to the bed. Since I'm happy with my first layer, I'm going to stop it just so I can show you what the first layer looks like. And that first layer might be just a little bit squished, but it's not too bad, especially for just using a piece of paper. So maybe we might want to go with a 0.35, but this is definitely going to stick and you won't lose your print. But when you're happy with your probe offset, you can just come back into Marlin and make that update. We're going to stick with our 0.4. And from now on, since you have baby stepping, if you need to adjust that on the fly, that's going to be available to you. And then finally, in your slicer, you need to update your start G code to run that leveling sequence before every print. This is Prusa Slicer, so we're going to head into printer settings, custom G code, and then after our G28, we can just enter a G29. After everything is heated up, this will home the printer, then run your level, and then I have a prime line running after that. But this will make sure that you're level every time you go to print. And there it is, the bilinear auto bed leveling setup is now complete. I do like to use inductive probes for the most part. I just think they work a little better, but no matter what probe you're using, this procedure is going to be very similar. Also, I showed you a lot more steps and features of auto bed leveling than you're probably going to have to use. It's just based on the type of bed that you use and maybe the specific points that you have to probe to get the bed level. Hopefully you found this refresher helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.